Hi everybody, today we're covering truth table basics. We'll cover negation, and, or, conditional, and biconditional. A truth table lists all possible combinations of truth values, either true or false, for statements and shows the resulting truth value of a compound statement. If we only have one statement, like P, then there are only two truth values possible, true or false. But if we make that bigger and include a second statement Q, then we need to think through all the possible truth value combinations of P and Q. So they could both be true, which would be 1, 1. P could be true and Q could be false, 1, 0. P could be false, Q could be true, 0, 1. Or P and Q could both be false, which is 0, 0. If we make that even bigger by having three statements, P, Q, and R, then we need 8 rows. You don't really want to have to think through all the combinations every time you make truth tables, so it's better to memorize patterns. With P, Q, and R, P starts 4 true followed by 4 false. Then Q we do in pairs, so 2 true, 2 false, 2 true, 2 false. Then R changes every time, true, false, true, false, true, false, true, false, all the way down. When we go back to PQ, we can also look at our pattern. P starts 2 true, 2 false, and then Q changes every time, true, false, true, false. Memorizing patterns makes it easier to set up your truth tables. Once we have our truth value set, then we can start talking about operations. The first one we'll look at is negation. A statement and its negation always have the opposite truth value. So when P is true, not P will be false, or when P is false, not P will be true. We can see that in our truth table, where P is true, not P is false, or where P is false, not P is true. Let's move on to putting statements together using connectives. Let's look at the disjunction or. For or, you only need one of the statements to be true for the combined statements to be true. That means true or true is true, true or false is true, false or true is true, but false, false is false. Conjunction and is more picky. With and, you need both statements to be true for the combined statement to be true. That says true and true is true, true and false is false, false and true is false, false and false is also false. So with or, we see lots of trues. With and, we see few trues. Conditionals are written if P then Q. Our symbols are P with an arrow over to Q. If P then Q means every time P happens, Q will happen too. What the conditional is telling you is to expect the second statement to occur every time the first statement occurs. So let's go through our cases. True implies true is true. The first statement happened, the second statement happened, that's exactly what we expected. But when the first statement happens and the second doesn't, that's a problem. The rule for implies says every time the first statement happens, the second one should too. Here the second thing didn't happen, so we say that's false. The conditional only tells us the rule for when the first thing happens. If the first thing doesn't happen, then the second one could happen or might not happen. So anything that starts false is automatically true with the conditional. So false true is true and false false is also true. So with the conditional, instead of remembering when things are true, we remember when it's false. True implies false is false, everything else is true. Biconditionals are written P if and only if Q. This means P implies Q and Q implies P. We write this with a double arrow. This is a much stronger statement than the conditional because we're doing P implies Q and Q implies P. We're looking in both directions. We've already looked at P implies Q, so let's look at Q implies P. We're going in the opposite direction. We start true implies true, which is true. Then we have false implies true. That's also true. Remember, if the first one's false with implies, it's automatically true. Next we have true implies false. That's the one that's false. The first thing happened, the second thing didn't, that's a problem. Then our last one, false implies false, we know that's true. Now that we have P implies Q and Q implies P, we can put those together with our connective and. Remember with and, they both have to be true for the overall statement to be true. True and true will be true. False and true will be false. True and false will be false. And then true and true is true. This column is the solution for P if and only if Q. So we can write that in our final column. The rule for the biconditional is matching is true. If you go back and look at the first two columns, you can see the biconditional was true when P and Q matched. Once we know the basics, we can make truth tables for any combination of statements, which we will do in following videos.